Hey everyone, in this video we're going to talk about section 3.5, which is about law of sines and law of cosines. You will need your trig identity sheet out as well as your calculator in degree mode. So, law of sines and law of cosines are going to be how we use trig to solve non-right triangles. So far, all of the trig that you know how to do always had the requirement that you had a right triangle. So with these laws, we're going to be able to solve other types of triangles. For this, we are going to kind of review our triangle congruence criteria that you learned a couple years ago in geometry. Don't worry, we're not doing proofs. And really what we're not even interested in proving our triangles congruent. We're more interested in about how these diagrams are marked. So for instance, when we had like side angle side, we had our angle included between both sides. So basically our angle was adjacent to both of the sides. Side had three sides. Right? Angle side angle had our side included or adjacent to both of our angles. Angle side, again, had two angles in one side, but in this case, our side was not included between the two angles. It was only adjacent to one side. And then side angle had one angle that was only adjacent to one side, so it was not included between the sides. So those were our 5 triangle congruence criteria. Technically, there's also hypotenuse leg, but again, that's a right triangle, so not something that we're interested in right now. Also kind of reviewing like what makes a triangle. Remember that we do have a rule that kind of talks about, well, what kind of segments could actually make up a triangle. On our trig identity sheet, it does list that out. We do know that the sum of any, let's highlight that instead. The sum of any two sides of a triangle has to be greater than the third side. So basically, if we had, let's say that I have a triangle with 3, 4, and 5, and those are the lengths of our sides. We need to make sure that if I choose any two sides, it always has to add up to be greater than the other one. So like 3 plus 4 has to be bigger than 5. That's true. 3 plus 5 has to be greater than 4. That's true. And then let's see, 5 plus 4 has to be greater than 3. That's true as well. So if you kind of go back to your geometry days, really the only one that we're interested in is if the two smaller sides are summed to be greater than the largest side, but technically the rule works for all of them. So then also if I think about it, like let's say that I have a triangle of 4, 4, and 10, well, if I take the two smaller sides and add them up, I know that 8 is not going to be greater than 10. So in this case, I would not be able to form a triangle. Okay. Enough of our geometry review. We're going to be taking a look at non-right triangles, which we call oblique triangles. The thing that we need to know here is basically how our diagrams are going to be labeled. So our capital letters are going to be our angles. Okay, and then our lowercase letters are going to be our side lengths. Okay, so whenever we're taking a look at our triangle, like let's say that I have angle A, I know that side length A is going to be the one that's opposite of angle A. Same thing with angle C, side length C or lowercase c is going to be opposite of that. Okay, so knowing how to read our information with the capital letters and lowercase letters are going to be able to help us set up our picture. So, okay, enough with all of this. So law of sines and law of cosines are going to be helpful when we're given specific types of information. So if we're given angle side angle, angle side, or side angle, we're going to use the law of sines. And the law of sines is down below, okay? So the law of sines says that the ratio between the sine of an angle and its opposite side will be constant for any triangle. So basically, I know that sine of A over A is equal to sine of B over B equals sine of C over C, okay? It's a fairly easy thing to derive. If you're interested in the derivation for either of the law of sines or law of cosines, I do have a video for each posted off to the side of this one. Not required to watch it, but if you are one of those people who wants to know where the formulas came from, they're actually pretty easy to derive, so I'd encourage you to watch that, but I'm not going to do that in this video. Okay. The one thing that we need to know about law of sines is that whenever we have a side angle case, we're actually going to refer to this as the ambiguous case. How do you spell ambiguous? Ambiguous case. Okay. We're going to be doing the ambiguous case and talking about that more in class together, so I won't be doing this in that video, or that in this video, but just know that there's going to be a little bit more work that we need to do if we are going to use side angle. If we have side angle side or side side side, we're going to be using the law of cosines. And the law of cosines actually has three different equations that we can have. We can have one with like an A, a B, and a C. We're going to choose which one we're going to use based off of the information that we are given. Okay. So again, these are all on your trig identity sheet over here. So you do not have to memorize them, and it even tells you which cases to use it for. So with that being said, let's go ahead and let's look at some examples. So in example 1, we're going to let capital A be 43 degrees, capital B be 57 degrees, and lowercase a is equal to 4.56 centimeters. We're going to find all of the missing sides and the angles of the triangle. For these directions of find all the missing sides and angles of the triangle, typically this can also be referred to as solve the triangle. Okay, so if you ever see those directions of solve the triangle, it just means find all of the missing stuff. Okay, so starting off, let's go ahead, we're going to draw ourselves a picture, and we're going to see the information that we have and which law we're going to use. So remember that whenever we draw a diagram, this is just an approximate diagram, so it might not be drawn to scale, but that's okay. Okay, so here we go. So there is my diagram. I have my A, B, C's, and then let's label. So capital A, angle A is 43 degrees. Capital B, angle B is 57 degrees. And then lowercase a is 4.56. And it does give us units, so I'm going to put those on there, centimeters. All right, so if I focus in on the information that I have one angle, and I have a side that is not in between there. So I think that we have angle, angle, side, which means angle, angle, side. If I come over to my trig identity sheet, angle, angle, side says that we are going to use the law of sines. Okay, so I know what I'm going to use now. I always like to also kind of just set up like off to the side, like some blanks of what I'm trying to solve for, so I know what I'm looking for. So I know that we need to find side length B, I need to find side length C, and then I need to find the measure of angle C. Or I can just call that capital C. Either one's fine. I'll even put a little degree thing there so I know that it's the angle that we're looking for. Okay, so here we go. We can really start anywhere that we want. We can go in order of how we wrote it, or we can try to find the easiest thing first. Personally, I actually think finding that angle C is going to be the easiest because we already have two angles in a triangle. We should know what all of the angles add up to be. It's 180. Okay, so I know that for angle C, I'm going to have 180 minus 43 minus 57. And if I type that all into my calculator, I believe we get 80 degrees. I will make one note. If I encourage you, even if I'm doing the calculations in the video, I encourage you to double check my calculations for me because I make mistakes and I want to know if I've made a mistake in this video because I didn't double check my work. So I'm looking for you to double check my work for me, okay? Okay, so we know that that's 80. And I actually am going to go ahead and I'm going to label that on my diagram because I'm going to try to solve it all so I know what I have. All right, okay, so we need to find the other side lengths of C and B. So whenever we're using our law of sines, I'm going to always encourage you to use the information that's given to you from the problem and not any of the things that we calculated. I would say that the angle C that we've calculated is probably pretty safe to use since we already had the two angles, but for the most part, let's try to use what we were given like up here, okay? So for this, let's find B first, okay? I see that I'm given an A angle and an A side length, so I'm going to use those to help me set up my ratio. One thing with our law of sines that we have is I have 3 of them that are given to us. We're always going to be focusing on 2. So like for instance, if I'm going to try to solve for my B side length, I'm going to ignore the C stuff because I don't really need to look at that because I'm going to use my A information I have and I'm solving for B. The C is not going to be important, okay? So just having all 3 of them equal to each other just gives you options of what you can use. All right, here we go. So I'm going to have, where do I want to write sine of A is 43 degrees, okay? And I'm going to divide that by my A length, which is 4.56. And I'm going to set that equal to sine of my B angle, which is 57 degrees. And I'm trying to solve for side length B. Okay, so there is my length, and then we're going to go ahead and we're going to solve this. Well, I know I can just multiply both sides by the denominators. So I'm going to multiply both sides by B, and then I'll multiply both sides by 4.56. Okay, so that'll undo my B's, that'll undo my 4.56's, so then I'll have B times sine of 43 is equal to 4.56 times sine of 57. Okay, and if I want to get B by itself, I'm going to divide both sides by sine of 43. So just solving the ratios. Okay. So it's going to leave us with B equals, I'm going to have 4.56 times sine of 57 in my numerator. And then in the denominator, I have sine of 43. All right. Okay, so I see I've isolated my B. I have everything ready to go. I'm going to go ahead and we're going to type this into our calculator, and then we're going to round to 3 decimal points. So when I typed it into my calculator, I got 608. Please go ahead and double check that to see if that's what you got as well. Okay, so I'm going to go and I'm going to write that here. 5.608. And we did have units, so I'm going to include units, so centimeters. All right. So now we need to go ahead and we're going to solve for C. Actually, I'm going to write this over here. So I knew that this was 5.608. Okay. Solving for our C, even though I found my B stuff, I now have like a complete B angle and a B side. I'm not going to use my B side length to solve for this because I've already gone ahead and rounded it. In class, we're going to talk about maybe one way we can get around that. However, I would say let's just go back and use our A things as well to solve for C. So that way we don't have to do anything more. So here we go. So I have sine of 43 over 4.56. And that's going to be equal to, okay, so my sine of C is going to be sine of 80. And then I have that over C side length. Even though the 80 was something that we calculated, I think we're pretty safe to use it. I know I said not to use something that you've already calculated, but the 80 was a nice number. Like there was no rounding involved with it, so we can go ahead and use it. Okay, same process as solving for C. Multiply both sides by the denominators to clear those out. Okay, so now I have C times sine of 43 is equal to 4.56 sine of 80. And then dividing both sides by sine of 43. We're going to get C equals 4.56 sine of 80 divided by sine of 43. Okay, so we have all of that ready to go. We're going to go ahead and type that into our calculator. I got 6.585. As my answer. So please double check that. Again, if I made a mistake, please let me know. Okay, so labeling it on my picture, I'm going to have 6.585. Okay, so one thing that I like to do, it's not required, but I do like to do it, is I always like to look at my final diagram that I've drawn and think, okay, does this make sense to me? And the way that it's going to make sense to us is just making sure that angle lengths match the opposite side lengths. So for instance, in a triangle, we know that the biggest angle is going to be across from the biggest side length. So like my biggest angle is 80, my biggest side length is 6.585. Those match, so okay, I know that at least that makes sense. Whereas like our smallest angle is 43, it's across from our smallest side length, so that makes sense as well. So I always just kind of like to do that just to make sure like, okay, is everything good to go? It is. So we're okay. All right, we are going to go on to question 2 next. Okay, so question 2, we're going to let C equal 37 degrees. A is equal to 8, and B is equal to 11. We're going to find all the missing sides and angles. Okay, so again, drawing ourselves a picture. Draw a slightly bigger triangle. Okay, so I have A, B, C, A, little b, and little c. All right, okay, so this time we're given angle C, so angle C is 37 degrees, side length A is 8, and then side length B is 11. So if I'm looking at what I'm given a side, that was not straight. I'm given a side, I'm given an angle and a side, so I think we have side, angle, side. So side, angle, side, according to our trig sheet, is going to be a law of cosines. Okay, so off to the side, I'm going to write all of the things that we still need to find. So I need to find capital A, the angle. I need to find capital B, the angle. And then I need to find lowercase c, the side. Okay. When we're looking at law of cosines, I know that we have 3 different versions, right? We have an A version, a B version, and a C version. We are going to choose the version that we have based off of the information. So for instance, I know that I'm given an angle C. And so if I'm just looking at like ones that I can cross out, well, I'm not given an angle A, so it's going to make this one not good to use. I'm not given an angle B, so it's going to be not great to use for this one. So we're going to use the C one because we're given that angle. That's the only angle we're given. So it's the only cosine of an angle that we're going to be able to compute. So I'm going to use c squared equals a squared plus b squared minus 2ab times cosine of c. Okay, so it's all about just thinking about like what's the information I have, actually being able to use it there. So it doesn't matter what we solve for first, we just have to pick something. I would say let's go ahead, let's solve for maybe side length c first, so then we have all of our sides to use. So when I do that, I'm just going to plug everything in. So I don't know my side length c, so that's going to be the variable I'm solving for. So I'm going to have c squared is equal to, okay, I know that a squared is 8, so I'm going to have 8 squared plus 11 squared minus 2 times 8 times 11, and that's going to multiply cosine of my angle C, which is 37. Okay, from here, I know what we're thinking. I know we're probably thinking, okay, well, let's start multiplying things through and let's get a single number over to one side and blah, blah, blah. No. Okay, in this case, all we're trying to do is we're trying to find this c squared. So instead of making small little algebraic errors of just simplification, I'm actually going to say we're going to type it into our calculator basically with what we have right now, okay? One thing that we are going to do, though, is I know I'm going to take the square root of this. So I'm going to take the square root of both sides. Okay, and then I know technically that would give me a plus or a minus here, but which one are we really going to have? Which is the one that actually makes sense? I hope to yourself you're thinking that's the positive version, because we're talking about a side length, and side lengths can only ever be positive, okay? So I'm going to have c equals the positive square root of 8 squared plus 11 squared minus 2 times 8 times 11 times cosine of 37. Okay, in your calculator, this is what I want you to type in, okay? Because we're going to save ourselves a lot of work if we don't accidentally make any algebraic errors, if we don't accidentally round too early. Let's just type it in like that, okay? So with all of the parentheses, all of the squared, everything like that. Okay, when you type this in, and I encourage you to type it in, check my work, I got that c is equal to 6.666. Okay, so again, just type it in like this. You don't need to simplify it algebraically at all. First, okay, so we found our angle C. Wow, no, our side length C. Okay, now we need to go back and we need to find angle A and angle B. So now that we're trying to find our angle A and our angle B, we are going to need to use these, okay? Because we're trying to solve for a capital A and we're going to try to solve for a capital B. And I know what you're probably thinking right now. You're like, oh, well, can't I use a law of sines or a law of cosine, or like the law of sines, because now we know a corresponding angle or side length? You could, but I would say let's not mix law of sine and law of cosine problems. If you're going to start with law of cosines, let's just use that consistently throughout. All right, let's solve for angle A first. So if I'm going to solve for angle A, I'm going to use the first one that actually has the capital A in it. So here we go. So I'm going to have A squared. All right. A squared equals B squared plus C squared minus 2BC times cosine A. Okay, so A squared is 8. So I'm going to have 8 squared equals B squared is 11. So 11 squared. Okay, and then this is where we run into an issue. Okay, so C is going to be one of the sides that we already found, right? And we calculated that out. So, I've preached, you don't want to round something and then use something that you've rounded later on. In class, we're going to talk about maybe a different way to go about this when we have the calculator out in front of us. But right now, what we have is the last thing that you should have calculated is this value of C, right? And we did round it because it wasn't initially 6.66, only 3 decimal places long before. So what we're going to do, I'm going to go ahead and I'm going to write in C squared here. But what you want to type in on your calculator, and again, if you can't find it on your calculator right now, let me know when you come to class. We are going to write in, like on your calculator, you're going to press the A and S button. You're going to recall that last answer so you can use that since that was the last thing that you calculated. Your calculator recognizes that that was the last one. Okay, so I know that's going to be C squared, but we're going to type it into our calculator as the ANS squared. Okay, so that way we're squaring that previous answer that we have. Okay, continuing on with this, so then we have minus 2. My value of B was 11. My value of C was ANS, okay, because that was my last answer. And then we're going to multiply by cosine of A. Okay, we need to go ahead. We need to try to get stuff by itself first. So instead of calculating everything out and getting numbers and having a long decimal that we're going to have to eventually round and it's going to get ugly, we're going to actually just manipulate what we have. Okay, so what I mean by that is we are going to just move these terms over. So like for instance, I would subtract my 11 squared and I would subtract my C squared or my answer squared. Okay, so if I did that, and I did that on both sides, I'd have 8 squared minus 11 squared minus answer squared, okay, so our C squared. And then that's going to be equal to negative 2 times 11 times C, or our answer, okay, times cosine of A. I see that I almost have my cosine by itself, but the only thing that we need to do now is all of my cosines being multiplied by all of this. So I'm on both sides, I'm going to divide by negative 2 times 11 times ANS. Okay, so now what I'm left with, I have 8 squared minus 11 squared minus ANS squared. That's divided by negative 2 times 11 times ANS. Okay, and that's going to be equal to cosine of A. So we're almost there, right? But how do we get how do we get the A by itself? How do we undo the cosine? We're going to take cosine inverse of both sides. So that means that A is going to be equal to cosine inverse of all of this. Okay, now, I haven't done any calculations. I haven't rounded anything yet. So this is what you're going to type into your calculator. So you're going to type in cosine inverse of, and then we just want to be careful with our parentheses. So typing it in, you want to make sure that you have a parenthesis around everything in the numerator. So I'd almost type this in as like 8 squared minus 11 squared minus ANS squared. And then you're going to do divided by And I'm going to be careful in the denominator. So I'm going to put a parentheses around the denominator so everything gets divided. So negative 2 times 11 times a and s, or that's c. Okay, so that's what we should type into our calculator. So calculating that, we have, I got that a is equal to 46.238 degrees. Okay, again, let me know if I did something wrong. So it's going to be our value of a. All right. So last thing that we need to solve for now is b. And you might be thinking, oh crap, we're going to have to do the law of cosines again. Not necessarily. Okay. So again, we now have two angles. I have the 37, which was given to me. I have my angle A, which was 46 point, a long decimal after, everything that I just calculated. We should, again, be able to subtract from 180 to be able to find that angle B. So that's exactly what we're going to do. Okay, so angle B is going to be 180 minus 37 minus our angle A. And when we have that angle A, and I go to type this in my calculator, I'm going to do 180 minus 37 minus our new answer, or the thing that you just most recently calculated, is this, in all of its decimal glory. Okay, so now I'm going to type in A and S again. I'm going to recall that answer, because now that's my new answer. That was the last thing that I calculated. Okay, and then that gets us around having to round anything. So 180 minus 37 minus that last answer, our angle B should be 96.762. That's what I got, at least. Okay, so going and putting that over here, 96.762. This is what we should have right now. So again, I always like to just look at my answer and be like, okay, does everything that I have make sense? Is everything in the right spot? So again, our biggest side length is 11. And so our biggest angle is 96-ish. So that makes sense. And then our smallest angle is 37. Our smallest side length was 6.666. Again, that makes sense because smallest side is across from the smallest angle. Whew, okay, so we've done one law of sines, one law of cosines. I'm going to encourage you. I would like to have you, before you come to class next time, I want you to try out number 3. Okay, number 3, you're given A equals 8, B equals 6, and C equals 7. So I want you to try it out. Okay, we're going to go over our answers when you come to class. And then I want you to try number 4 as well. Okay, so try number 3, try number 4. Again, if it doesn't go well, we're going to talk about them in class. But I do expect that those are done before you come. Next class period, we're going to talk about the ambiguous case of side-side angle. So notice none of the ones that we've done so far have to do with that. That's going to be what we tackle in class together. So that is all for this video, and I will see you all later.